So we're going to do a little bit of an exercise in a little while, and asking a little bit about your background will help me as we go through that. Okay, so this is why we're all here, right? These are our numbers that we're dealing with when it comes to produce food safety in the United States. Aha, I think I found the clicker. Let's see if that works. Right, so about 1 in 6 Americans every year get sick from something he or she eats in the US alone. And that can be produce or not produce, right? Some of those end up in hospitalizations, and some end up in deaths, unfortunately. Right? We are all working towards reducing these numbers. And when it comes to produce, perhaps we're seeing an unfair bit of media attention. We certainly have seen a lot of produce outbreaks in the past couple of years, and in this session in particular, we're going to talk about why that is and what's going on about that. So when we think about what causes these outbreaks, it's really looking for that proverbial needle in a haystack, right? If we were to look at this beautiful field of romaine out in Salinas, California, and try to identify a pathogen there, it's nearly impossible, right? But as we'll talk about today, the FDA is undertaking that test right now. They are actually sampling fields like this and looking for pathogenic bacteria, something that's never been done until just now. And so we'll talk over the next little bit about some of the data that's being collected around that and some of the questions that are being raised as well. So if we look at produce in terms of the number of illnesses and percentages of illnesses that we see, certainly leafy greens are a large player in this, right? They make the media. Many people eat them, so we see illnesses that are tied to that. And unfortunately, that's brought in a lot of media attention and maybe even more scrutiny that follows that, right? The other large block up there is for sprouts. Sprouts are something that have caused more illness in the past. We don't necessarily see them tied to illness now, perhaps because there are new task forces that sprout growers are dealing with, and they're really being held to very strict standards when it comes to food safety. Of course, if you're familiar with the Food Safety Modernization Act and the Produce Safety Rule that's now going into play, there are very strict standards that are being put on now for all produce growers. We'll talk a little bit about that as we go forward. You can see a variety of other commodities up there as well. Papayas have been in the news the past couple of years. Certainly cucumbers in this area have caused many different outbreaks over several years. Melons historically have been involved with salmonella contamination. It's difficult, right? We're asking a really difficult situation here. We want to try to safeguard produce that's growing outside when we have lots of different microorganisms that might come into play. So it's not easy to try to reduce the risk, but we'll talk a little bit today about how we might do that. So if you haven't seen this sort of was breaking overnight. This is an outbreak associated with romaine lettuce, and it's associated with illnesses actually in the state of Maryland, so where we are today, that are associated with this salad mix that was purchased at Sam's Club. Now, there could be others that are tied to this as well, and there's some mixed communication, I think, that's coming out right now. So Consumer Reports is suggesting not to eat romaine lettuce again. The industry is pushing back on that right away, suggesting that they don't have enough information. But what can consumers think? Because this is actually following on the heels of an outbreak that the FDA says just ended earlier this month, and that was sort of pushed under the table a little bit. It was not brought out into the open. So just a few weeks ago, there were at least 23 outbreaks across 23 illnesses across multiple states that were associated with Salinas-grown lettuce. So when we think about a lot of the lettuce that is coming to us this time of year, it's coming from the central coast of California, and pretty soon that's going to be moving over into Yuma, Arizona, as they start to shut down some of the production facilities there in California and move into Yuma. And so, consumers are left wondering again, is romaine lettuce safe? And as we all know, what happened last year at Thanksgiving, right, where all romaine was taken off the shelves because they were not able to pinpoint exactly where it came from. And so there's a lot of questions that go into this. And so here's what we're waking up to this morning. kind of unfortunate situation. So let's do a little bit of a microbiology recap, just to make sure that we're all kind of on the same page, and we'll talk a little bit about bacteria, viruses, and protozoa, the ones that you might hear about in the news, the ones that we should be kind of thinking about. So when we talk about bacteria when it comes to the produce safety rule, we're talking about generic E. coli, non-pathogenic E. coli. And that's what we're usually testing water for. We all have non-pathogenic E. coli inside us, in our intestines. We rely on it for our ability to digest food. And when we find it in the environment, we know it's an indicator of some kind of fecal contamination, either from humans or from animals. So it gives us a picture of what could have happened in the environment, but it doesn't really tell us whether or not that product is safe or contaminated, right? But it's sort of the best thing that we have. So a lot of people, when we think about bacteria in the environment, we're thinking about generic E. coli. Now, if we turn to the outbreaks that happen and the bacteria that cause illnesses, we're thinking more about zoonotic bacteria, which are ones that can be transmitted from animals to humans and are in the environment. So we might think of salmonella, and that can come from birds, lots of different avian species, or reptiles or amphibians carry them, sort of their normal flora on their skin. So there's often ongoing outbreaks with the cute little slider turtles and chicks and hedgehogs, a lot of those pocket pets that people play with and handle and then don't wash their hands necessarily, right? So we think of salmonella occurring from all of those types of animals in the environment. And of course, they can make their way into fields, right, and into farms. Then the Shiga-toxigenic E. coli are related to our generic E. coli, but they have specific genes that can make us very, very sick. And so this is the one that's causing all the problems with romaine lettuce that we hear about. It contains a specific gene that makes this thing called a Shiga toxin, and what that does is actually targets your kidney and can lead to organ failure, especially in young children. And so that's where we see the deaths that are associated with these outbreaks. It's a very efficient pathogen, and it only takes a few cells to make you very sick. And so that's why the FDA is now testing romaine lettuce for specifically looking for Shiga-toxigenic E. coli. Another organism that you're hearing about in the news is Listeria monocytogenes. So this bacteria actually likes to grow in the cold. So this makes Listeria different from all the others because it can grow in your refrigerator. And so we hear frozen foods being recalled for this, sometimes fresh lettuce being recalled, not necessarily tied to as many illnesses that we hear about in the news, but it definitely can cause very serious illnesses. In fact, it's linked to a lot of deaths in terms of people who are immunocompromised, the elderly and pregnant women in particular. And so that's why this one is usually such a concern, and we hear more about it with recalls than we do with active outbreaks, right? But it's a very serious organism. So what can we do to try to reduce the presence of some of these? We'll talk a little bit about that as we look at the pre-harvest environment in a few minutes. Why is it important to think about how we handle our fruits and vegetables and think about cold chain, right? Cold chain is really important when we're trying to either remove field heat from produce or make sure that we get produce cold and we keep the trucks cold as they're coming across the country, for example. Thinking about how bacteria grow, right? So we have one bacteria and it'll actually split into two. Those will split into two and two again. So they grow through this generation time here where you can see we might start off with just 100 and very quickly, right, in a few hours, so here we go, hours for 100 to 1 million, we can very quickly get to 1 million cells, and that could make people very, very sick. So in order to try to reduce this, we can do things pretty simple like keeping fruits and vegetables colder, right? And so that's really an important fact. The other thing that we can do when we think about processing food is that we change the environment so that bacteria won't be able to grow. Now that's difficult when we talk about a whole mango, right? Or a head of lettuce. We can't necessarily change that environment very much. So what we rely on there is cold. But when we think about bacteria growing in the environment, they do, and this is kind of an old adage, this fat Tom, where we think about bacteria like food, so they like to be able to grow. So if you have a cleaner lettuce leaf rather than one that has soil on it, they don't like acid, which is why we tend to not see a lot of bacteria associated with acidic foods. They will grow, as we just saw, over time. They tend to not like cooler temperatures, except for Listeria, which will grow slowly at cooler temperatures. And then when we remove the oxygen, they tend to grow less rapidly, for sure. And they like moisture. So we're going to talk about this last one quite a bit today when we think about rainfall and other aspects of the environment. So moisture is going to be really important for our discussion today. So just to take just a little bit of a break, we'll think a little bit about cleaning and sanitizing, right? And this is going to get us into Listeria, right? So where does Listeria come from? It comes from the soil. It's actually a soil microorganism, and so it can make its way into any processing plant or into a packing house pretty easily, right? And Listeria likes to grow in something that's called a biofilm. So when you wake up in the morning, you feel that lovely little sweater on your teeth. That's a biofilm. Or anybody have pets? You ever have to clean out a water bowl for a pet, right? That's got that kind of layer of slime. That's a bacterial biofilm. And so bacteria love to grow in that. This is a picture of Listeria growing in a biofilm. So these are Listeria cells. And here you can see all of this webbing. And these are actually sugars that they're secreting, and they're able to connect to each other. And so you can imagine if this is on a conveyor belt or even on a lettuce leaf, how would you get in there to clean this off, right? You'd have to really go in and scrub it to try to get rid of this. You wouldn't just be able to dump sanitizer on this. You'd have to really get in there and clean that off. And this is the way most bacteria live in the environment. We're not going to find free living cells. And so when thinking about how important cleaning and sanitizing is, it really is what we're doing to try to remove this. So these are just 4 images that actually come from the produce safety training that we do for all growers. And this is really a critical step, right? I think we sort of underplay how important cleaning and sanitizing are across the food chain. And when you hear about recalls, especially those for Listeria monocytogenes, typically there was an error in sanitation, right? So it's easy to think about, yes, we need to clean and sanitize, but it's not that easy to do, right? Because you need the right cleaner, the right sanitizer. You need people that are educated to do that. And a lot of times that means having specific tools, right? You might have color-coded brushes that you use for one specific area. If this is the side of the room where the raw products come in, I'm not going to take the same tools and use them where the finished product is, right? So you'd want 2 different sets of tools for that. But you can have different ways of cleaning and sanitizing. This is just an example, just to make sure that the surfaces are scrubbed first, and you remove any of the dirt before you come back with that sanitizer. And then, of course, using a sanitizer that's approved for the specific food contact area that you're doing. And there are a lot of those that are available. There are long lists of those that are available that are approved for organic use as well. So there's lots of alternatives. And this is important really for any area of food production, even for thinking about where I'm moving manure or moving soil amendments or something like that, making sure that those different tools are going to be cleaned and sanitized properly.
How frequently is it? Daily sufficient most of the time? Or?
Yes, or sometimes not even. You can do it every few days, depending on how soiled they get and what else you might be doing with them.
Just practical.
Yes. So it doesn't have to become a burden. It's just important that you're doing it, and then you're logging that you're doing that. Yes. Great question. Yeah, please, if there's any questions at all, stop me. So let's mention now a little bit about viruses. So we don't hear too much about them in terms of large outbreaks or recalls, except for maybe if you hear about norovirus and people not enjoying their cruise as well, right? We tend to hear about that. Although, interestingly, norovirus on cruise ships causes less than 1% of all outbreaks. So they tend to make the news, but we have a lot of norovirus, right? In fact, many people still call it the winter vomiting disease. So we're entering that season, flu season and norovirus season, as we're all tucked in inside. And it can be transmitted through food. In fact, it's transmitted quite often through lettuce. And so we have to think about how are the viruses getting onto our products. So viruses are kind of weird. They're very different from bacteria. They don't live on their own. They're just a protein coat surrounding a piece of nucleic acid. And what happens is you ingest that virus, maybe on a lettuce leaf, and that virus infects your host cells and kind of hijacks the ability to be able to replicate itself. And so you can always make lovely Halloween stories and things like that, right, around about viruses and how they replicate and then burst and then are able to kind of take over and make you very, very, very sick. What's interesting now when we think about testing and produce safety are frozen berries. Right, so frozen berries are more popular these days. Everybody wants a healthy smoothie in the morning. They have a very long shelf life, so we can buy them and think, I'm going to make lots of smoothies and then leave them in the freezer for a while and then start back on the smoothie kick, right? That's what happens at my house. And so what we see is recalls for frozen berries because the FDA actually started doing testing at the end of last year on frozen berries. And so they're randomly checking throughout retail all different frozen berries, and they're looking for these two viruses, hepatitis A virus and norovirus. So hepatitis A you might have heard of. This is also a fecal-oral transmission. So this is not a blood-borne hepatitis. It gets its name, though, because it can affect the liver. And it has this really long incubation period. So when figuring out an outbreak associated with hepatitis A, you have to remember what you ate a month ago. Right? I'm not even good. I mean, today is Thursday. Don't think I could tell you what I ate on Monday. Right? So how can we remember a month ago? It's very difficult to figure out what causes an outbreak when it's associated with hepatitis A. But we've seen historically frozen berries that are involved in outbreaks the past few years. Now, these are not all berries that were domestically produced. Many of these were produced abroad and imported. And so there's, of course, a lot of questions that can be raised that way when we think of what kind of food safety do we have implemented around the world. And so this makes it a very global question, making sure that everybody is doing the same thing when it comes to food safety that's being imported. And so that's a part of this discussion as well. So I wanted to mention a protozoa called Cyclospora cayetanensis, because you might be hearing about Cyclospora in the news. And Cyclospora causes a long, prolonged diarrhea. You could be sick for a week or two, and then most likely you'll recover. And there are some treatments, so if you have that, you can go to the physician and you can get treatment. This is a really different type of microorganism, though, because it's an oocyst, and so these are shed only by humans. That's what we believe, only by humans. And something like this, which is about 8 microns in size. So while these are huge compared to bacteria and viruses, so if we think about the size of a virus, about 1,000, well, more like 1 million viruses will sit on the top of a pinhead, right? And maybe 1,000 bacteria on top of a pinhead. So we've got a big size difference here. These are huge compared to the others. So you can't see them with the naked eye, but you can look at them with a microscope fairly easily. And you can see they have a very odd life cycle. So they would be ingested by a human, and then in the intestine, they undergo asexual and sexual reproduction. And then these oocysts are shed in fecal samples and in human feces that then make their way into our food supply. So we just mentioned a little bit about global food production. Right? Up until last year, Cyclospora had been a problem with imported produce. And we've seen that since the 90s. And then we had outbreaks 2013, 2014, 2015, 2016, 2017. And then last year, we saw domestically acquired Cyclospora, meaning that we have this organism now in the US, getting into our food supply. And there were 2 fairly big outbreaks. So this is what's called an epidemic curve, and we're going to look at those today quite a few times. And what they do is it's a way to take a snapshot of an outbreak. So we see all of the different illness onset dates here, and each date is different. And sorry, you can't see this, but we just want to look at the shape of the curve. And then the number of people. So if we've got 10, 20, 30, 40. So on each day, there are many people that have gotten sick. And this first outbreak here was related to lettuce that was part of a McDonald's salad. And then there were 500 people that were sick with that outbreak. And then this one was the Del Monte vegetable tray. And so it was actually found to be on broccoli that was grown in the United States. And there were almost 300 people that were infected in that outbreak, 300 confirmed cases. And so why are we mentioning this? It's because it continues, right? From 2013 up through 2019, we've had hundreds and hundreds of people in the US getting sick with this microorganism. So it's something we need to think about. And scientists and the FDA are really trying to figure out what can we do to reduce these numbers. And I think awareness and education is a really important part of that. So this was a defined outbreak that happened earlier this year that was associated with basil. This is a basil that was imported from Mexico. You can see it happened across multiple states. And outside of this outbreak with this known product, we had domestically acquired cases of Cyclospora where we have no idea what food was involved. And so that's very frustrating, I think, to the scientists that are involved in this. And I actually work with this in my lab group, and we work with the FDA trying to understand what's happening. But I think to consumers and producers, this is exceptionally frustrating because I tell my growers to think about their water that they're using, educate and make sure that their handlers are washing their hands well, and that you're using the porta potties properly, and those are getting drained, and everything is being taken care of that way. But it's a bit frustrating that we can't say, here's where it's coming from. So this is just one of those big challenges that hopefully over the next year we'll have a better answer about what's happening. Right now we're doing a lot of surveys trying to figure out where it is in the environment and how is it getting here, how is it getting onto our produce. So keep looking out for that in the news. Okay, so let's talk a little bit about how outbreaks are actually investigated. Yes.
Slide.
Yes, sir.
Would that be something that we get from leafy vegetables, right?
Yes.
And broccoli?
Yes.
All right, so now, as a consumer, if I wash mine with soap and water, does that eliminate this or reduce it?
It could reduce it, yes. It may not eliminate it completely because of the way that they're attached, the way that they're stuck to that produce. It will reduce, it has a good chance of reducing it. All of these microorganisms that we're talking about are all killed by heat. So you can always turn to cooking fruits and vegetables as a concerned consumer.
So I start eating wilted lettuce.
A grilled romaine salad. We actually haven't seen too many outbreaks with like head leaf lettuce. So that's at least one good point. Yes, right. So when we've been talking about these different outbreaks, I want to go over a little bit about where we're seeing this, like where are we getting this data and what's the process, right? So there are 3 different stages to determining when an outbreak happens, and they all kind of start the same way. Someone calls and says that they were sick, right? I ate something and I don't feel well. Or I ate something, I don't feel well, and now I'm going to the hospital. And so that hospital can take a test, can do a test, can take a stool sample, and can determine whether or not there's salmonella or Shiga toxigenic E. coli or cyclospora that made you sick, right? And so then all that data comes together as part of networks where there are discussions across the country. And a lot of this is now between multiple state departments where they communicate through databases, extensive databases. They come up with questionnaires and ask you, what do you remember eating? And that's why that food recall part is so important, because that's what all goes into figuring out what might have been in common. And so this beginning piece is tricky, right? And so this is why we just finished an outbreak with romaine lettuce, but we really didn't even hear about it, and it went on for a couple weeks, right? Or maybe even 2 months. But it took that long to figure out this piece. And so I think something else that consumers get very frustrated about is why does this take so long, right? Well, it may take days or even weeks to do the testing in the laboratory. And the FDA and the CDC and the various state departments are fairly cautious before going back and implicating a food product. And sometimes, if we look at what happened last year around this time, right at Thanksgiving, they were not able to say which farm that contaminated lettuce came from. They didn't have enough certainty, and so what happened? Well, we had a tragedy, basically, when it comes to romaine lettuce, because we wasted a lot of food, right? And so food security is a really big issue when it comes to all of this, but it's better to err perhaps on the side of public health, right? And so that's when we see those kinds of things happen, unfortunately. And this little last bit down here on this CDC infographic is really important. They're constantly improving, always trying to make this faster. So a little bit of a recap, and then I have kind of an exercise that we'll see if everybody wants to work through. We have just a snapshot of what happened in 2018. 2018 was a tremendous year for foodborne outbreaks. Right? There were more than we've had previously. Some of these were quite big. We had the 2 very large leafy green outbreaks. A lot of people ask, do we have better technology? Is that why we have more and more recalls? And that's in part, yes, because the FDA is out looking for things, so we have more recalls. Companies are doing testing, right? If I am Walmart, right, and I'm going to buy your leafy greens, I'm going to ask you to do some specific tests before I purchase that. So we have a lot more of that kind of built into the infrastructure. For good or bad, that's happening. And when you find something, you find a pathogen, then you have to have a recall, right? And sometimes they're not found in time, and then we have the illnesses that are attached to that. Just a little peek at what's happened this year. Something a little bit quieter. So these are not all the outbreaks that have happened. These are select ones that were involved with multi-states that were investigated by the CDC. So this top one here, unknown, is actually the romaine lettuce that just finished, and then they haven't added the one, of course, that was released today. You can see a variety of different foods. There's the basil that we just mentioned. Flour is something that we see a lot now because the bacteria are surviving the processing. Not quite sure how they are getting through that. There are a lot of scientists that are working on that. But of course, there's a lot of education that we need around that. It's about time to make lots of Christmas cookies, right? Holiday baking. Perhaps don't let the flour go all over your kitchen. Be more careful about cleaning it up. Don't eat raw batter, those kinds of things. Okay, so if you're all game, I have something for us to do just for a few minutes. Thank you. So, and maybe we can do this as a group, if that's all right with you. So what you're getting is a little packet of information. And the top sheet tells you about an environmental investigation. So what's happened is that there has been a recall of romaine lettuce, and there are illnesses that are attached to this product. And so now, as the growers and producers of this lettuce, we want to figure out why that lettuce might have been contaminated. And so if you're all game, we'll work through this together, okay? So on the first page, you have that information. So there's 187 people who are sick from this produce item. Okay, we don't have to blame lettuce. We could say it's any produce product that we want. So we're involved in solving this outbreak, and our role as the outbreak investigator is to evaluate practices and conditions that may have contributed to the contamination of the implicated product. Your job is not an easy one. Concerned producers, manufacturers, distributors, regulators, and consumers are relying on you. Okay, so if you look at those couple pages that you have an epi curve. So this shows you the dates of the illness onset. And I'm going to give you another piece of information if you'd like to write on this. So the earliest exposure that we know of, based on all the questionnaires and the people we've talked to involved in this outbreak, is April 18th. Okay, so we think that's when people were first exposed. And then it takes a few days for the bacteria to work its way through the host, and then we had people starting to get sick. Okay? So let's look at the data that we're given. Because what is really great about what's changing in terms of food safety is that regulatory groups and producers and growers are all looking at lots and lots of data. I mean, I think when people talk about big data, the food world has the biggest data. I mean, we collect data on everything. So you have two sheets of data here, these different raindrops. So we have region 1 rainfall data, and we have region 2 rainfall data. And if you look at those, and you just kind of run your fingers across, and you're looking at the date, so everything's in order. So we start on April 10th, and we keep going. Do you see a lot of rainfall occurring sometime between April 10th and April 18th in either of those regions?
Region 1.
In region 1? Yes. And when do you see rainfall occurring in region 2?
Not till the 23rd.
Right.
But the outbreak had already started.
Right, when the outbreak had already started. So if you were going to go back and say rainfall might have had a part of this outbreak, which region would we look for? 1, right. Excellent. So this is actually, if we were going to plot it out, we would add our rainfall data here, right? And there's quite a bit of rainfall that happened. And we see this quite happen a lot, don't we now, with climate anomalies that are happening. We have a lot of rainfall. We actually have a lot of flooding that happens. And that is something that's really changing food safety risks. So in this case, when we look at those two different regions, this rainfall could have added moisture to those bacteria that could have been there. It could have washed bacteria into that area that weren't there originally, and that could have contributed to this outbreak. And so these are important findings for us to be thinking about.
When you say wash,
Yes.
is that a splash factor, the rain hitting the ground?
It could, absolutely. So we could have splash, you could have regrowth actually on the leaf, or you could even have movement from manure piles or farms nearby, or you could even have flooding if it was really bad out of streams or things like that. Yes, all of those would be important factors. So this brings us to kind of the next section that we want to talk about, and that's thinking about these pathogens that are in the environment, right? They're not all equal. They don't all cause disease the same way. But what can we do to try to reduce their presence from maybe here, water or manure, soil amendments, onto our crops? And when we think about these pathogenic bacteria, like the Shiga-toxigenic E. coli that's causing the current outbreak, these bacteria are not supposed to be happy living on lettuce leaves. They're supposed to be happy inside the gut of an animal or inside a human host, unfortunately. They're not supposed to be able to live on these lettuce leaves. So this is what I just mentioned, where FDA is actually testing now romaine lettuce. This came out on November 15th, this bit of news. And this is a follow-up to last year's outbreaks and this year's outbreaks, where they are now sampling and looking for pathogens. So as I mentioned, that's not really easy to do, and I'm anxious to see what kind of results that they find. So I want to show you two graphs that deal with this rain question, right? And this is work that we did at University of Delaware several years ago, and we grew leafy greens in 2013 and 2014. And here, the red bars are relative humidity. We've got a very humid environment here in the mid-Atlantic area, right? And that is very conducive to bacterial survival. So bacteria can survive in the soil or in water for long periods of time. The good news is they don't survive on lettuce leaves for very long. But look at these two. So the blue and the purple are spinach and lettuce leaves. So on this 0+ day, we actually add bacteria through water, through irrigation. And so this is the amount of bacteria that we added. Look over day 1 and day 3. What happens to those bacterial cells? They die because they're not very happy on that lettuce leaf. So they die pretty quickly. But when we add rainfall into that mix, so here, and it always happens when we do a study, we always get rainfall, right? We can't predict that, but it just happens in this area. So here we got 1.7 centimeters. And what happens? We see a little bit of a spike, a little bit of regrowth in bacteria. But they die off again. But then when we have 9 centimeters, one day, that's a lot of rain, and 3.5 centimeters, what happens to the bacteria then on the lettuce leaf? A huge increase, right? And so what's the takeaway from this? If you don't have to harvest right after it rains, wait 3 days. Thank you. Right? So if we look at 2014, pretty much the same data, right? We see that when we added the bacteria, here we've got what we added. They start to die off pretty quickly, and they die differently on the spinach versus the lettuce, right? And so we think about how commodities might play a role in that as well. And then as soon as it rains, they go back up again. That's another thing about romaine lettuce, right? If it's sitting like this, upwards, you might have rain or dust that's being able to bring pathogens sitting inside that beautiful head of lettuce. So we'll skip that. Okay. So another thing I wanted to mention is that we've been doing a lot of studying the water that's in this area, right? And so people want to be able to use water for irrigation. We want to be able to help our growers be able to save groundwater and use pond water or stream water or river water whenever they can. One really good bit of information is that in 2 years of testing, and this is a very large collaborative group across University of Maryland, the USDA ARS, University of Delaware, and University of Arizona, we have found very little Shiga toxigenic E. coli in this area, right? So that's very good news. We found a lot of salmonella, which we might anticipate because we have a lot of wildlife, right? So I think this is where it's coming from. We also have a lot of domestic animals in this area, right? And so salmonella may be coming into the water from poultry production as well. We also find Listeria monocytogenes, which is not a surprise because it's a soil-borne microorganism. So what we're doing now is trying to understand the presence of these bacteria. And so we looked at a variety of different types of salmonella that we found, and there are thousands of different types of salmonella. Some of the ones that we found are likely to be associated with human illness, and some are not. Some are really ones that we see mostly with wildlife. And what we're doing is working now with the FDA to understand what it means to have these in some of our water systems and trying to understand these microorganisms. We're also trying to correlate this with what's happening in the water. For example, on very turbid water samples, we were more likely to find salmonella. So again, if it rains and there's sediment is getting stirred up and you're using a surface water source, don't use that to irrigate until it settles down, right? So there are important takeaways that we can get from this kind of information. Okay, so let's spend the next few minutes looking at the 2018 outbreaks and trying to understand what happened there and what can we take away from that. So this is the Food Safety Modernization Act. I'm guessing many of you are familiar with different aspects of that. So the produce safety rule went into effect over the last 2 years, really with growers across the world having to meet specific standards when it comes to the amount of E. coli that's in their water and then how they're handling their soil amendments. Also, education is a really big part of this, right? How do we educate our workers so that they have familiarity with food safety, so that they're cleaning and sanitizing properly? All of that is really important. So we often think of these 4 W's, right, where we can have risks associated with them: workers, water, wildlife, and waste in the form of manure. I'm encouraging us to think about that a little bit differently, to think about it in terms of health of ecosystems, right? So we're thinking about what's the health of the animals that are in that ecosystem, does that affect our health, and how does that affect the health of the environment? We term this One Health, and this is a really nice way for us to think about the connections that are happening. And so it's a term that's been used for actually hundreds of years, but it's one that veterinarians are starting to use more frequently, and we're seeing physicians start to think about it too. And so you might hear about that in the future. Okay, so this was the first outbreak that happened in 2018. This is the product that was grown in Yuma, Arizona, and was linked to 210 cases, 96 hospitalizations, and 5 deaths were attributed to this romaine lettuce. Right? And when the FDA finished their environmental assessment, which happened in June, right? So that's the problem with these outbreaks, right? We have an outbreak that happens, it takes so long to get all that data to figure out where it came from, to assemble the FDA team to go and do the outbreak investigation doesn't happen until there's no more romaine lettuce that's being grown in this area. Right? That is a huge disadvantage, right? So we need things to be faster, but we also need we need certainty, right? We need good data. We need to make sure we know where you're supposed to go to do that outbreak investigation, right? So here they found the outbreak strain. They found the outbreak strain in the canal water. So I want to show you a little bit about what that means. So here we are, right? This is Yuma, Arizona. This is the traceback that's involved in figuring out where that came from, right? So these are all of the different retail establishments where the product was sold. We have to go backwards to distribution centers. We have to go backwards to farms. So this is the part that's not so easy to figure out where it came from. And what you might notice now is that they have labeling for where your product was grown and where it was harvested, to try to reduce some of that food waste that was happening. So this is an image that comes from that environmental assessment by the FDA. So this is the canal. So all of the green are all different fields where lettuce is being grown. And right here in this area in brown is a huge concentrated animal feeding operation. So not a good placement, right? As you think about produce grown here in the Mid-Atlantic, we try to know our neighbors a little bit better, right? There are more rules now about distances that have to be in between if you're going to have animals and product like leafy greens, but this is very expensive land, right? So we have a lot of commingling of different growers. In this canal here, this is where that they found the outbreak strain. I want to mention quickly, one big factor that could have contributed to this outbreak was freezing temperatures. What happens to leafy greens when they freeze? They become brittle, right? They spoil, they blister. So here they didn't spoil completely, but they might have blistered. And so then if you have dust, so we had blistering romaine coupled with fairly strong winds, not crazy strong, like 16 miles per hour, 30 miles per hour, I think at one evening. The others were 11 and 16. So you might have had wind coming across, right? And so that could have been pretty devastating to this outbreak. This is another close-up where they were sampling, and they sampled all of these different places and did not find the outbreak strain. So it's not very easy when looking for pathogens, even when you think that you could probably find them here.
Don't they use sprinkle irrigation to protect freeze animals too?
So they don't here necessarily, but in many parts of the country that we do. Yes, absolutely.
That would add to the potential.
Yes, it could, especially if it's close to harvest. Yes. So the outbreak that happened last was the one that happened in California, and again, they found this outbreak in sediment by water. Again,
Is that E. coli strain, is that animal and or human
yes,
possibility?
yes. Most likely animal because we're finding it in the water, and there wasn't a sewage contamination event that happened that was known of, but you're right, it could have been either way. So we'll just finish up real quickly that I've given you a lot of information. Hopefully you can think of how some of it might be able to apply to you, what you can do with it in terms of risk communication, right? How do we talk to people that we're working with? How do we put these things in perspective that might affect us here. And then just want to thank you for your attention, because food safety is definitely local, right? And so I just thank you very much for your time.
Thank you.